So we continue on to example 3, where they get a little more complicated in terms of applying the different properties of exponents, and within each example we'll probably find that we're going to apply several different properties of exponents. So let's move to example 3, which begins on slide 20 of the PowerPoint posted in Canvas. So in part A of this example, we do see that we have two quantities inside parentheses, but really the parentheses are unnecessary in this case because there are no exponents outside those parentheses. There's nothing here or here. So we can just think of this as basic multiplication. So first I'm going to take the coefficients and multiply them together. 3 times 4 is 12. And then I'm going to take the x's and multiply them together, and we know that this is a case in which we add those exponents. So 2 plus negative 3 is negative 1. And then finally I'm going to take the y's and multiply them together, remembering that this y has an exponent of 1. Here again we add our exponents, so negative 4 plus 1 is negative 3. But once again we're not finished because we have to get rid of our negative exponents. Anything that does not have a negative exponent stays where it is. So first, the x to the negative 1 is going to move to the bottom and become x to the positive 1, no longer on top. Second, the y to the negative 3 on top is going to move to the bottom and become y to the positive 3 on bottom and be eliminated from the top. The 12 stays where it is. So on top, what's left is only the 12. On bottom, x, y cubed. There's your final answer for part A. In part B, we have this expression and we're asked to simplify it. So we look for any common variables. So I notice I have an A on top and I have an A on bottom. This involves division, so I know that I subtract exponents of like bases. I'm going to divide the 12 by negative 3, and that's negative 4. Okay? A to the 3 divided by a to the negative 1 would be a to the 3 minus negative 1. And then b to the 2 divided by b to the 5 would be b to the 2 minus 5. So if I simplify that at this point, I've got negative 4 out in front. 3 minus negative 1 is the same as plus positive 1, so I have a to the 4 power. And then b to the 2 minus 5 would become b to the negative 3 power. And now I need to move my negative exponents. The only negative exponent is b to the negative 3. So it will move to the bottom and become b to the positive 3 and no longer be on top. Now you might say, well, what about that negative 4 out in front? That is not a negative exponent. That is a negative coefficient. So it just stays where it is. So what we end up with for our final answer is negative 4a to the 4th over b to the 3rd power. And finally, example 4, we have 2 to the negative 3 plus 3 to the negative 1. So first of all, I want to recognize that they each have a negative exponent, and I want to make them positive. So for the 2 to the negative 3, I'm going to move it down to the bottom, and it's going to become 2 to the positive 3 on bottom, and that will eliminate it from the top. And for the 3 to the negative 1, I'm going to move it to the bottom, and it's going to become 3 to the positive 1 and be eliminated from the top. So what I basically have here at this point is 1 over 2 to the 3rd, which is 8, so 1 over 8, plus 1 over 3 to the 1, which is 3. Well, those can be combined if I get common denominators. The common denominator would be 24. So I'll need to multiply the top and bottom by 3. And for the second fraction, I'll need to multiply the top and bottom by 8 to get 24 on bottom. So now I have 3 over 24 plus 8 over 24. And we know now that our denominators are the same, we merely add our numerators, and we end up with 11 over 24. If there were any common factors of 11 and 24, we would be expected to simplify, but there are none. So if you have any questions or would like any additional examples, please don't hesitate to message me through Canvas, and I will certainly make them for you.